Okay, welcome everyone to our fourth panel of Data Innovation Day. My name is Joshua New. I'm a policy analyst at the Center for Data Innovation. So I'm going to moderate this panel, which is titled Innovations in Analytics, Activation, and Big Data Technologies. In this one, we're going to get into the nitty-gritty data science and talk about some of the data innovation from a perspective. So joining us, we're very pleased to have Michael Wild, Chief of Awesome at Splunk, who I believe wins the best title of anyone today. I'm sorry, guys. Mark Silverman, the CEO of TreeMiner. David Sears, a data evangelist at Tableau. Christopher Surdak, who, among other things, is an author of the book Data Crush, How the Information Tidal Wave is Driving New Business Opportunities. We have Sridhar Iyengar, who's a distinguished engineer at IBM's T.J. Watson Research Center. And then we also have Angel Pizarro, Technical Business Development Manager at Amazon Web Services. So thanks so much for being here. As we start and you talk for the first time, feel free to give a brief background about your organization and some of the work you do. So this panel will, as the other ones, will be a mix of moderated discussion, roundtable discussion, and audience Q&A for people watching at home. Feel free to tweet us with the hashtag data innovation, and we'll hope to answer some of your questions. It looks like viewers are trickling in. Again, so big thank you guys for being here. And to kick off, so innovations in data science are happening so quickly. It's hard for people to keep up. So what changes have you guys seen specifically in the past year that has had a big impact on business? How have these recent innovations transformed the way businesses approach strategy? And feel free to, whoever wants to jump in.
Yeah, hey, this is Wild. Yeah, I'm Michael Wild with Splunk. The Q title is Chief of Awesome. But I've been with Splunk since the early days, almost about 8 years from now. And what Splunk focuses on is we build a platform or an engine for machine data. So all the data that gets generated of all the, machines that we work with, from elevators to trains to web servers to networks to you name it. And what we've sort of seen is customers making huge strides by being able to see human and transactional behavior as a result of what's coming out of the machines. Like, we've seen people take elevator data coming from elevators, data coming from card swipes, and a company in Japan that manages thousands of office buildings. If you think about it, if you have that much machine data, you're kind of omnipotent at that point. They're actually able to use the machine data as a predictor of economic activity if people are going to renew their leases. There's all sorts of really cool use cases that are coming out of the machine data world, whether it's networks and servers and cars and Internet of Things, and that's really been the exciting thing that we've seen and had a lot of success with over the past 10 years at Splunk.
Yeah, this is.
Go ahead.
Sorry. This is Mark Silverman. I'm the CEO of TreeMiner. We're actually a relatively new software company that's focused on developing predictive classification algorithms, and we work in both streaming data and big data environments. I would concur. I mean, we're seeing a lot of machine data as well. From our perspective, what we're seeing is kind of an increasing level of, let's say, complexity with respect to the types of predictions or predictive classification tasks that folks want to do with their machine data. For example, we're working with folks that are doing real-time vibrational analysis to predict, failures of machines, as an example. Just really kind of much more, I'll say, complex analytics. The second thing that we're seeing is, and I think, kind of alluded to before, is just an increasing diversity of the sources of data, and people are wanting to fold in many different types of data streams into their analytics to get much more complex and relevant results back. So those are the kinds of challenges that we're seeing.
I'll grab. So Chris Surdak with Hewlett Packard, data guy for them, I guess. And I don't know if you guys, I think you guys are saying the same thing, but there's almost been a point of inflection over about the last 6 or 7 months. Previously, 99% of companies I talked to were doing what I call big BI, big business intelligence. It's the same old questions of the same old data. It's just a petabyte instead of a terabyte. And then they have the expectation of, I'm going to get disruption from that, and that's irrational. Of course you're not going to disrupt. You're asking the same question of the same data. I think you guys are touching on it. There's now new classes of data that I'm plugging into, both machine data, Internet of Things stuff, and unstructured stuff, audio, video. And the people that are starting to succeed in big data are taking data sets they've never looked at before, combining them, and then asking questions that weren't askable before. And that's the real distinction for monetization and business success in this whole arena.
So this is Sridhar Iyengar from IBM. Can you guys hear me?
Yes.
Okay. Yeah, so I'm at the T.J. Watson Research Center working in our cognitive computing research team. I think the area that a number of us are focused on is at the intersection of what was just mentioned, the gentleman from HP, structured, unstructured, and also not just getting what I will call typical BI insights out of it, but get insights out of the unstructured information. I think for those of you who saw the Watson beat Jeopardy a few years ago, a couple of recent things that are worth mentioning is we have an insurance company beginning to use unstructured data in a question answering mode, so that when somebody calls in for customer service, they're actually speaking to Watson behind the scene that's mining the unstructured information and responding intelligently to questions. Another interesting example I will touch on, which my colleagues are working on with a bank in Singapore, is to help a financial advisor not just work with your portfolio, but also at the same time gather insights from SEC filings or financial reports, which is a ton of unstructured information, and using that to help prepare the financial advisor do a much better job at what he or she would typically be doing. So in a sense, the recent innovations we're seeing is combining structured and unstructured streaming machine data, but really to augment and scale the intelligence that domain experts have in specific areas, so that others who aren't as expert could also get value from these insights.
Sridhar, could you give a brief explanation to people watching who might not be familiar with the term? What constitutes structured versus unstructured data, and what are the challenges of working with unstructured data that has been, I guess, it's looming over the heads of businesses trying to make sense of all the information they have?
Sure. So structured data is what we've always worked with in relational databases, or before that, the hierarchical databases. There's a schema, there's a defined structure, whether in XML or SQL, that tells you what are the classes or the tables and the attributes and the relations. In the case of unstructured data, think the stream of information that's coming from an ECG, or X-rays from a X-ray machine, or just all the voice that we're just talking, and the video that's there that's part of this Google Hangout. All of these are unstructured, and there aren't very good, well-defined query languages and optimization techniques for processing this kind of data. So if you think of the billions of tweets that come every day, or the millions of emails with attachments that are passing everywhere, a lot of that is unstructured information. So having the ability to query, gather insights, and get useful information out of this massive data is a huge problem. It's a scale problem. It's the type of structures that are very, very different. And the technology to really do an optimized search for all of these, we're still, I would say, in the early days, even though the industry has been making progress. There's a ton that still needs to be done.
I think that's correct. This is Angel Pizarro at Amazon Web Services. And, the few touch points that we've had are, the scale, the volume, the variety of data coming in, and this whole issue about unstructured data, which could be, doctor's notes, they could be tweets, they could be anything that you can't really rely on specific items of information to be in every single record that you inspect. The other major category of change that I've seen over the years in the big data and business intelligence and data analytics space is actually the tool development, the tool sets that you have available to you, where those tools came from, and the platforms that you can run them on top of, right? Previously, to do this well or do it at any sort of scale, it required really pretty large investments in specialized architectures. That's just not the case today. And the software really moved from proprietary systems to open source based software, so the Hadoop infrastructure is obviously a huge one in the data analytics space. And these are things that came out of academic labs, were adopted by industry, but then as they iterated on top of these software platforms, they actually provided it back to the community in this virtuous cycle of giving back, getting iterations, and then taking that open source software into the next level of being able to handle the types of data that we get these days.
Yeah, this is David Sears from Tableau Software. We specialize in data visualizations and working and letting, if you will, the common man be able to look at their data. And I think the big change that we've been seeing over the last 10 years of being in this industry has really been, how do I get the proper tools to users to start making actionable decisions? The gentleman who mentioned about Big BI, we've seen that go down. People try to work with the technology, and yet I'm sorry to say right now, but the state of the art for a data analyst a lot of times is just an Excel spreadsheet, which certainly doesn't lend itself to big data by any means out there. But they're struggling to be able to get access to the data, and we're starting to see with Hadoop coming along very nicely, as people have said, the unstructured data. We're starting to be able to access interesting data sets and seeing people try to make a real data-driven organization and not necessarily fly by gut, but by actually actionable data items out there. It still, to me, is amazing the quality of analysis or lack of quality because they can't get at data.
I think the comment made on the lack of...
Everyone loves to talk about a data lake, and it's this very pristine and beautiful sounding thing, and I'm going to go hang out by the lake, and it's going to be lovely. And what we actually are seeing these days is data swamps. They smell, they're ugly, they're very unproductive, and you dump a lot of stuff into it, and nothing really comes out that's clean. We got a long way to go there. The other challenge, too, with Internet of Things is you have quintillions of rows of data coming every day, and the vast majority of them say, nothing just happened, nothing just happened, nothing just happened. Now, and the one of a trillion times that something interesting does happen, how do I find it in a time frame where I actually can do something with that insight?
So going off that, actually, I to interject, Mark Silverman, I believe TreeMiner has taken an interesting approach to this. So so that's known as the analysis bottleneck, where you have, especially with Internet of Things, when you have thousands and thousands of new sensors being uploaded, and you have so many new sources of information, and it's all disparate kinds of information. It's not necessarily data that can communicate with each other. How should companies go about approaching this this swamp? How can they actually start getting value out of it? How can they move forward?
Right. So thanks for the question. And yeah, so we're doing something a bit innovative in the way we actually do the classification of the analytics, which is that we iterate actually over the attributes of the data rather than the rows. So when you have a situation, for example, it was just talking about kind of quintillions of rows of data streaming through. Really, our view is you do have quintillions of rows, but those rows generally contain a small number of attributes, and so if you can figure out how to iterate over the attributes and find those, 1 in a quintillion points you're looking for, you can get significant performance advantages. And so that's the approach that we've taken, and we've gotten it working actually in streaming environments, so you can do it really on the fly. But there are definitely huge challenges. This is really at its infancy in terms of how do you visualize quintillions of rows, or how do you visualize the results coming from quintillions of rows in a way that makes sense to somebody and that they can act on it quickly.
Well, and emphasizing the act on it quickly part, and I call it action at the speed of insight. There's no point in knowing what your customer's doing second by second if it takes me an hour to respond. And in fact, that's a bad thing. I'm going to piss off my customer. I'm going to tick off my employees. So I have to. Everyone's focused on customer data and market data and so forth right now in big data. You got to fix your internal operations, or you're hosed. You've got to be able to. Your business processes were not designed to operate at this pace, and if you don't re-engineer internally, there's no point in knowing what's going on out there second by second.
Yeah, I would agree with that. I think we've talked briefly on the role of a data scientist. I think your point on data swarms is exactly right. There is a whole bunch of garbage that needs to be cleaned up, and trying to get value out of that's not easy. I see another term coming up, and maybe a new profession, a data curator. So making sure that you have the right data, the right quality of data, the right veracity of data, and making sure that the queries are on that is going to become more and more important. So just so right next to the data scientist, you will also see a need for a data curator as a new role that you will start seeing showing up in many organizations. And we talked about tools. Tools for data curation will also need to start getting more mature to make the lives of all these folks who are going to be curators a little easier.
So by curator, do you mean somebody from a data quality perspective, data governance of what's coming out from the different data sets?
Yes, but this curation is not just the structured data, it's the unstructured data. It basically spans all of the data, and this is the person whose responsibility is to at least clean up what's possible and make sure that, let's assume that you're building an analytical application to cure cancer. You want to make sure that the documents that you're reading and analyzing are the real medical records, and the journals you're reading are from reputable organizations. So all of this would be what I would call falls under the umbrella of data curation.
So, Sridhar, I'm glad you brought this up because this is something we wanted to talk about. You know, as companies increasingly rely on data science to drive operations, there's an immediate need for data scientists, data curators, whatever role these people with this specific education can fill. But certain industry analysts have claimed that there's going to be a shortage. You know, supply of data scientists cannot keep up with demand. What can companies do to prepare for this? Or is it something that has to happen on a broader level? Is it a policy shift? Is it an education issue?
So I think all of those. You're beginning to see data science programs showing up in many universities. In fact, I'm advising University of North Carolina and their staff on what their curriculum for data science should be. So more and more of this needs to happen. And it's also not just about data science. As I mentioned earlier, it's about the intersection of all of the data, structured, unstructured. You bring in cognitive and learning and machine intelligence. So there needs to be a curriculum that's much more broadly focused on all of these aspects, machine learning, AI, and we see that as part of what needs to happen in schools and in companies and individuals educating themselves, and also through things like the Cognitive Institute. You can go out to LinkedIn and see a reference to that where you can get educated on that. So I think all of those need to happen. I think there is clearly a real dearth of experts in this area right now.
If I may, I am extremely skeptical of anyone who claims to be a data scientist these days. It's like 1999, and if I was a barista, I claimed to be a Java expert. You know, and you see this all the time on LinkedIn. Everyone in the world is claiming to be a data scientist now. I want to talk to the person who was doing statistical analytics on clickstreams 10 years ago before it was sexy, and the challenge for companies that are trying to hire data scientists, you have to have at least enough expertise to know if someone else is actually an expert when they claim they are. And if you don't, then you're not going to be able to make any kind of appropriate assessment of those people.
And that brings up kind of another kind of issue, which is that very often what I see is that people don't even know the right kinds of questions that they can ask, right? So people are kind of stuck in some ways figuring, wanting to ask relatively sort of basic questions against these new data types, this unstructured data, without realizing kind of the world of possibilities. And it kind of makes it hard to bring in a data scientist when you're not really sure what you want to get out of your data.
Yeah, regarding a couple of points people have made, I think it's actually too early I mean, the data lake idea is not even really mature enough yet to say we're in swamp territory. But the whole theme and spirit. A friend of mine at Coca-Cola, who's a architect of consumer systems, Michael Connor, said, like, they look at things as the current state is like a data cartels, where people are holding on to data for whatever reason, and you might need to solve a problem and you just don't know it's out there. So, the lake idea is good. So just start putting data in this lake. Don't worry about what you're going to ask. Don't necessarily worry about designing the lake with a set of questions in advance. But the other point is, yes, there's a lot of people that have data science on their resume and on LinkedIn, but I think we're going to see, or we're going to need to see, a shift in corporate culture that data matters. At our user conference, Michael also said, without data, you're just another person with an opinion. Okay, so when somebody enters a meeting, the person that talks the loudest gets the most attention and often can sway the meeting. But if we start pushing people in the direction that, great opinion, but where's your data? Then, there's a lot of tools out there that help people explore and answer questions. I think it's bigger than tools and bigger than lakes. It's a lot more about people and changing their opinion and ideas on what I can do and how I can be successful, and making data as a backbone behind that.
Michael, that's awesome, Michael. And I tell people all the time, if the stuff you're doing out of all of these analytics don't make you uncomfortable, you're not trying hard enough and you're failing. If all you're doing is proving what you already know, don't go through this exercise. It's a waste of time and energy. You should be up at night, staring at the ceiling at 2 in the morning, saying, what am I going to do with this new insight? It's very scary to me. That's how you know you're getting this right.
I would also venture that as we go out in the world out here, we have to have the ability to tell a story about our data. As we look at all this information that we're getting out there, a lot of people aren't going to be the heavy-duty stats person who can understand all the different things. We have to be able to explain to them and tell the story that our data is pushing out there. I think part of the thing for companies is to be able to, as people have said on this call, I've got a lot of data out here. I can't just do the same old, same old. I have to look at new insights and be willing to experiment, try, see different things, see if I can get new meanings out of all this new data that I'm getting out there. But then again, I have to be able to communicate it to all the people out there what my vision is, and be able to tell that story to say, here's how I see the data and here's the progression I made to come up with this decision, and explain it easily to people.
All right, and just a friendly reminder to all the viewers who may not have been on when we started, feel free to tweet us questions at #DataInnovation. And one, we touched on it briefly, but this one comes from Twitter. How can data visualization specifically help us transform simple data collection and reporting to actually driving actionable insights, to improving outcomes? So how is this technology, how has it changed this process so far, and what do you hope to see for the future of data visualization? Excuse me.
This is Dave Sears again from Tableau. We have seen a lot of different things happen with data visualization. It's our bread and butter out there. The biggest thing is the way that it's helping people have insight jump off the page, if you will. We've typically been looking at business intelligence reports, lots of rows and columns. I'm old enough to say I know what a green bar report from a mainframe chain printer was. And we had a hunt and peck looking for information versus utilizing visualization to see things. I work with the Department of Defense. They were tying together with black box data and looking at approaches for people coming in on runways and tying it together with like sleep cycles. And they could see that if they were on the downside of their sleep cycle after a lot of flying, they were twice as likely to make errors coming into it. So they were able to get very quick insight into, wow, maybe we need to have more rest so that people have a different sleep cycle at that point in time. So we're seeing this be able to really sift through a lot of data that is kind of all the norm, the easy pieces, and see the exceptions where we need to see where we're doing well or where we're not doing so well.
So yeah, this is Sridhar. I would agree with that. I think this whole area of visualization using a variety of techniques, I absolutely agree that I think we see enough of these bar charts, etc. New visualizations that can look at massive amounts of data and just bring out what is changing. I think the gentleman from Tableau mentioned visualization when things are changing, trends. Imagine the instrumentation that's actually happening within a hospital. All of the patients being seen, their vital signs. If you think about the old way of doing things, you're looking at a few charts. If you could see all of that live and have a visualization that highlights what's interesting, what are the abnormalities, making that clearly visible to the appropriate physician or nurse, I think new types of visualization techniques are absolutely key. And in fact, I think more breakthrough here, I think, is a way to get better control of the data. It helps understand things better.
Great, thanks. And so we talked about visualization. Visualization might be the most obvious, at least, way to see data science in action in a business. So it could be data science, or it could be visualization, excuse me, it could be something else. What specific, the big data technology, if you want to lump them all together like that, has been the most transformative for business, or what do you see it being the most transformative in the coming future as the technology develops? Is it cloud computing? Is it visualization? Is it predictive analytics? Is it something more I guess, a little more sexy like artificial intelligence?
Well, for me, I have sort of a digital trinity, I call it, and it's mobility, it's predictive, and it's cloud. You put those three things together, and that's where the epic changes are going to come from. Visualization to me is only really relevant if you can predict if you're visualizing future events, because visualizing the fact that my patient died yesterday really doesn't help me that much. But visualization helps to consume vast quantities of data. But it's again that digital trinity of mobility, cloud computing, so ubiquitous infrastructure, and predictive analytics that are really the game-changing trio.
I might offer a counterpoint to that, in that visualization, it might be a stepping stone for everything else. So if you can't see how your data is working for you or what the information you're collecting, you can't do a whole lot of anything else with it.
I'm just saying, by the time you rendered the image, the opportunity is already gone potentially.
Yeah,
I think both of you are right. I think you need to visualize, but if you don't have the user experience, we could be doing lots and lots of interesting things and optimization in the back end. That won't be apparent. I think the fourth thing I would add to that is learning. I think there is so much data that is out there. You can have the cloud, you can have the visualization, you can have the analytics and the predictive analytics, but if you don't build learning systems, the level of complexity that exists is so much that certain problems are just not tractable. So I would add learning systems, and this is where I think some of the work we're doing in the cognitive area is important. I think will make a huge difference in transforming not just professions, but many industries.
I agree, Sridhar, and especially for predictive analytics and healthcare, it's going to be extremely important to have better learning algorithms and data ingest and outcomes research to be brought back into the clinic in a faster time frame that usually happens now, especially post release of drugs as we get into the population with recent compounds that come onto the market. We have to be able to go back and inform the science of that compound as it hits the population and be able to put back more items on it. So yes, learning is important. And for visualization, I think that everybody thinks of visualization as a really fancy charts, and visualization could just be how do you rank things in a table, right? When you show it to them, and does the ranking of items change over time? It doesn't have to be something fancy. It can be something quite ubiquitous and easy to understand as a table, but the ranking really actually matters, and that's where the user experience and design really come into the visualization frameworks.
And I think that kind of what makes this point in time really kind of cool and interesting from our perspective is that really it's not any one of these things that are driving innovation in big data. It's the fact that they're all happening together. Innovations in virtualization and cloud computing, open source platforms like Hadoop or Storm or Spark or what have you, and innovations on the predictive analytics side, like what we're doing at TrueMiner. So all these things coming together, I think, is really what makes this a really cool point in time.
Yeah, I would have to say one of the biggest things is machine data. I mean, what's going into Hadoop? Massive amounts of machine data, massive amounts of transaction data, massive amounts of stuff that's not a result of a human typing something in. And the tools that are out there are now to the point where you can start to ask questions, visualize things, and get insights from what the machines are telling you that weren't even possible by just looking at the human data. On the other hand, to the point of visualization, there are a lot of things that you can't just figure out from the charts. You need to see it played back over time. If it was people amassing in an area in a hospital, or a certain number of people leaving a town that was under a hurricane, us humans have the context behind the particular area that even the most advanced machines can't necessarily figure out with a high degree of reliability. And so some of the visualization technologies that will let you play back stuff over time, visualize things that are going, they're really helpful because it gives us a chance against the robots, basically, before we're all put out to pasture.
Michael, you touched on something I say to customers, clients all the time, and that is big data is a terrible name for what we're into. It's not about bigness and it's not about data. It's about better questions. And I think that's what we should be calling this whole revolution, because it's about asking a better question and now actually having the ability to answer that with new insights and with more data than we ever had before. But it's all about the question and the new answer.
Yeah, for some people, big data is 64,000 rows in a spreadsheet. That's big, just because it's like important, but it's not about the bigness. You're right. It's about what you can get out of it and how important it is.
For a lot of people, big data is about deploying a Hadoop cluster and wondering where the money comes out. Lots of money goes in, but money doesn't necessarily come out. You have to actually ask something new and innovate.
Yeah, and I think the other question really for us as we take a look at this is that most organizations have multiple data types, data sources, if you will, whether it's Oracle, Hadoop,
Are we back?
Yep, I'm back. Did we lose I think we lost everybody else, huh?
People reconnect in a sec. We're coming back. We broke Google.
I blame North Korea. So does everyone else, so hey.
We lost our moderator, but he'll be back.
That's all right. He'll just,
Now we're free to say whatever we want, right?
yeah.
Yeah. No. Hey, this has been fun.
He's back. Daniel's back. Yeah.
So, Michael, one of the things you're talking about is IoT, and we're all completely obsessed about IoT, and I think it's hugely disruptive. The thing, it's almost a little passe, so the thing I'm already starting to talk to people about is the IOU, and that's the Internet of Us, and that's where with bionics and digital tattoos and stuff, we're going to be friending our livers on Facebook, and they're going to be telling our doctors on us when we have too much to drink at night.
Yeah, so sorry to everyone. It looks like we had a little bit of hiccup there, but I believe everyone is back with us. Looks like we didn't really lose any viewers. So sorry if I missed any of that conversation. I'd like to shift gears a little bit. We've talked about some of the shortcomings of data science, as it's a relatively burgeoning field. Companies aren't quite comfortable approaching it in the way they should. They're not asking the right questions necessarily. They're not visualizing their data quickly enough to make actionable decisions. So shifting gears a little bit on the other side of the coin, what are some of the success stories we're seeing? What is being done? Either your company's done it, or helped someone else do it, or you've seen it in the private or public sectors that that business has fundamentally changed because of these technologies, for the better.
Oh yeah, totally. There's a really cool video on Splunk.com of this company called New York Airbrake. I think they saved the rail industry a couple of $1 billion. like seriously, by taking the machine data off of the trains, because their job is to tell the trains when to brake and when not to brake. So what happens when you brake too late? That's bad, right? What happens when you brake too early? A giant pile of fuel gets used unnecessarily. And that's probably one of the most awesome business-changing things that I've seen. I mean, they've integrated into their complete development process, so they actually can coach and train people, but they're able to use data coming off of the machines to make actual better business decisions and save millions and nearly $1 billion in fuel. And that was like one of the most surprising things that we ever saw that somebody might do with data in this age.
Sure. We have, again, so if you might have not have noticed, I work in the medical field. I do genomics and life science research prior to joining AWS, and currently promote genomics and life science markets here. And we have a great case study of science that wouldn't have happened without the infrastructure and platforms that you get these days. Bristol Myers Squibb had done some clinical trial simulations, and they're able to do many, many, many more clinical trial simulations to reduce the cost of when they went to a phase 3 clinical trial. They could actually direct that trial to come be more powerful with a smaller population set, which means that they can get this compound through phase 3 trials faster and onto the market, and additionally make it a safer molecule and a safer trial, because they could restrict the set of patients that it would be safe to give this medicine to. So I think these type of techniques are not only good for business, they're also good for human health and human safety and human condition overall.
Yeah, Michael, to your point, we're doing something similar with the transportation industry in Japan, helping them do maintenance on the rail. And I will say this about the Internet of Things: with enough data, the mundane can become fascinating and incredibly valuable. And again, it's asking questions you didn't ask before that could be the billion-dollar answer once you put that data to proper use. But it is about asking new and different questions. Who knew that optimizing air braking could save that kind of money until you asked?
Yeah, and also I think now we're getting to the point where systems are starting to push their data exhaust out, in real time or in some latency, where 10, 15 years ago you just couldn't find out how your sprinkler system was doing. You couldn't ask how your car was doing. That's probably one of the biggest innovations, is finally we're able to get something out so that, like Chris said, you can start to ask questions.
Great. So we have about 6 or 7 minutes left. We're going to close out at 3:15. So looking to the future, I guess it's a two-part question. So of the technologies that we're familiar with today, visualization, cloud computing, machine learning, predictive analytics, the whole list of those, what do you think has matured, and what do you think is really only in its infancy? Or is that the wrong way of thinking of it? Are all of these going to evolve equally as we get new data sources, new applications, new methods of collection? Or are some really going to take off more than others to be more useful and be more transformative? What kind of trends do you expect to happen?
So this is Sridhar. I would say you will see innovations in all those areas, but I think working with domain-specific data, for example, medical data, how do you read an X-ray? How do you really understand what's in an X-ray? How do you really interpret what we are talking about in this Google Hangout and get some insights out of it? So I think domain adaptation, understanding different industries and getting insights within the context of those industries, I think a ton needs to be done in this in terms of innovation. I think in the whole area of dealing with all of these different types of unstructured data, I think we're really in the infancy. I think we made some good progress on text. Very little, I would say, in image, even little in complex images like CAT scans and X-rays in the medical domain, or video streams in the entertainment domain. So analytics on different types of data, and in the context of different industries, there's a ton of innovation that needs to happen. I think we're still in the infancy here.
If I may, I think our biggest challenge is actually us. in our organizations, we're going to innovate like crazy, and there's going to be no slowing that innovation down. In fact, it's accelerating. The greater challenge is, are we prepared to deal with the implications of those learnings? Are organizations and bureaucracies ready to fundamentally change how they work and be fundamentally disrupted and operate at 10 times the speed? And I think the answer is generally no. And that's how you get Ubered or Airbnb'd or whomever. That's how these guys move in. And I tell companies all the time, look, if you're highly regulated, highly structured, look for some startup of 5 guys in a shipping container in Lagos, Nigeria, and they're going to do what's technically illegal, and they're going to blow you out of the water in 6 months. That's the new normal. Get used to it. So I think the greater challenge is organizationally, how do we adopt this stuff and apply the learnings that we get in a way that's effective?
Yeah, I would add on to that. It's really going to be about, a lot of times, especially working in the federal market space, public market space, it's about acquisition plans. How do I innovate quickly? Things change almost overnight, and to try to come up with a new areas to try out new technologies and to afford them and be able to build them on them, that's going to be one of the challenges we're going to have as we go forward. You see more and more organizations going to cloud and putting their data off premise and be able to trust that the security is going to be there, that I'm not going to get hacked and different things. I think we're going to see a lot of interesting things coming up. I think we're seeing a lot of collaboration between different types of technologies. I think that's going to be important for us. And not one size fits all, but we're going to be interleaving software from different organizations to come up with a better whole as we go forward.
And which kind of raises the question or challenge, I think, which is, how do you, just on a very practical level, right? How do you put all these different pieces together in a way that makes it very accessible for people to use? And I think there's still a lot of challenges in that area as well.
I think another area where I think we need to see some breakthroughs is we're building all these quote-unquote smart systems. How do you actually build systems that can work with you, me, and the subject matter experts in specific domains? And how can this collaboration between man and machine be more symbiotic in a manner that serves the society? I think we'll need some significant breakthroughs in that area. Otherwise, there'll be a class of what I would call data challenged or information challenged people who will get left out of the woodwork if we don't make this work well.
Yeah, I would characterize that as self-selective irrelevance. I mean, you better know what Akai distribution is in this day and age, or you're going to be flipping hamburgers until a robot does it. Becoming data literate should be every professional who wants to remain professional your number one priority, and literally you will be left behind in short order. Some of the work I'm doing, like with the International Monetary Fund and the World Bank, there's going to be 1 billion new entrants to the middle class by 2025, and none of them will be in Western society. These are people that make $20 a week with PhD level educations, and the minute they plug into the internet, they can't tell the difference between you, me, and them, and that's what we're competing with. So you better get up to speed, and you better do it quick.
That's great. So we still have about 2 minutes left. Just a reminder, a quick notice to all the people that are watching. The new panel, when it starts, you'll have to refresh our website for the video to load, just in case you're wondering where it went. So finally, if you could just give me brief thoughts. Every year, more and more companies are investing in these technologies. Whether or not they're approaching it in the right manner is surely up to debate. But still, I believe the last number I saw was about 25% are not planning on investing in what's in these big data technologies. Why do you think that is? Is it an attitude adjustment? Is it a technical barrier? What can be done to drive adoption? In the last minute we have.
I think it's probably a lot to do with business culture, and quite frankly, not all businesses need big data and innovation within it. I think it has to be a well thought out decision whether you bring these technologies in your business, because it is outside of the scope of it. But for a lot, I think that answer will be yes, and we need to change our culture, and we need to retake a look at what innovation actually means. So that we can implement these systems.
I think looking out in the future, if companies don't really embrace data, whether it is big, small, or different variety, I think they'll become dinosaurs. I think data is at the center of the universe in terms of producing and deriving value. I think we need all of those other technologies. Yeah, you need cloud. Yeah, you need mobile. But without data, what are you going to show? What are you going to serve? What are you going to explore? So I think it's at the heart of everything.
On that note, if that could sum up the panel, that'd be the great soundbite. So thank you so much for being here, panelists. This video will be uploaded immediately as soon as we are done onto our website. You can watch it from the beginning. Thank you so much for being here, and please stick around for our next panel, New Businesses in the Data Economy. So thank you so much, guys.
Thanks a lot.
Bye.
Thank you.